Hello, 6th grade math students. This is Chapter 4.3, Part 1, Real-World Problems with Ratios. Today we're going to learn to draw models to solve problems involving a single ratio. In Part 2, we'll learn to solve problems using two ratios. Our first problem asks us this. Megan prepares a fruit punch using apple juice and orange juice in a ratio of 4 to 3. If the total volume of the fruit punch is 630 milliliters, find the volume of apple juice that Megan uses. We'll begin by drawing a bar model to help us solve this. We'll represent the apple juice as 4 equal units. We don't know exactly how large those units are, but we know that there are 4 of them. And we know that for each of those 4 units of apple juice, we have 3 units of orange juice. That are of equal size. Finally, we know that all of this together equals 630 milliliters. So what do we do to solve? We're going to take the total number of units we have of apple juice and orange juice, and we're going to make those equal to our 630 milliliters. So we have 1, 2, 3, 4, 5, 6, 7 units that are equal to 630 milliliters of punch. To find the value of 1 unit, we're going to divide both sides by 7. And 630 divided by 7 gives us 90 milliliters. So each one of these units is valued at 90 milliliters. All right, so to find out how much apple juice Megan uses, we need to take 90 times 4. Because there are 4 units of apple juice. So 90 times 4 will give us 360 milliliters. So Megan used 360 milliliters of apple juice to make 630 milliliters of punch. Let's try another question using this same original setup. In this next part of the problem, we're going to be given a quantity of apple juice and then need to calculate the volume of orange juice used. So if Megan uses 520 milliliters of apple juice to make punch, what quantity of orange juice will she use? Once again, we'll draw that very same picture. So we'll have 4 units of apple juice and 3 units of orange juice. Please pardon my not exactly perfect unit squares here. We know that the apple juice units are equal to 520 milliliters. So we can calculate the value of each unit by taking our 4 units, setting them equal to 520 milliliters, divide each side by 4, so that 1 unit will be equal to 130 milliliters. If each one of these units is worth 130 milliliters, we can calculate the amount of orange juice used by taking 130 times 3, like this, giving us a quantity of orange juice that's equal to 390 milliliters. So Megan used 390 milliliters of orange juice to mix with her 520 milliliters of apple juice to make the fruit punch. Now I want you to try a problem like this on your own. I'm going to help you get started with the bar model, and then I'm going to ask you to do the calculations by yourself. A box contains baseball and football cards. The number of baseball cards to the number of football cards is in a ratio of 5 to 1. If the total number of cards is 1,380, find the number of each type of cards. Here's what our bar model will look like. The baseball cards have 5 units. and the football cards have a single unit. We know that this total quantity is 1,380. You solve from here. We want to know how many baseball cards are there and how many football cards are there. Press pause, work through this problem, and when you come back, we'll complete part B. Now let's move on to the second half of this problem. Suppose that our number of baseball cards is 950. How many football cards will we have? Well, I bet you can see a quick and easy way to solve this using equivalent ratios. But let me also show you how to solve it using the bar model. Once again, we'll draw that bar model that shows that baseball cards contain 5 units and that football cards contain 1. We know that the baseball cards equal 950. So how would we calculate how many cards are in each unit? And then calculate how many football cards we have. Go ahead and complete this problem, and when you are finished, come back and we'll move on to our next idea. In these next problems, we're going to draw models to solve ratios that have 3 quantities. Here's our first example. Jenny prepares a ceramic glaze mixture of feldspar, which we'll represent as F, iron oxide, which we'll represent as I, and silica, which we'll represent as S, in the ratio of 5 to 2 to 3. The mass of the mixture is 1 kilogram plus 200 grams. So the entire thing equals 1 kilogram plus 200 grams. Find the mass of each ingredient used to prepare the mixture. So we'll begin by drawing a bar model to represent the number of units of each ingredient. So the feldspar has 5 units. The iron oxide has 2. And the silica has 3. We know that the total mass is 1 kilogram, 200 grams, which we could also write as 1,200 grams, correct? Because a kilogram is 1,000 grams, just to simplify this a little bit. So the total number of units is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 units equals a mass of 1,200 grams. Each individual unit has a value of 120 grams. Now it's a simple matter to go back and calculate the mass of each ingredient included in the glaze. The feldspar, with 5 units of 120 grams, would have had a mass of 600 grams. I'm going to go ahead and write this up here as a new ratio, okay? The red iron oxide, with 2 units of 120 grams, would have had 240 grams. And finally, the silica, with 3 units of 120 grams, would have been 360 grams. So the mass of the feldspar was 600 grams, the mass of the red iron oxide was 240 grams, and the mass of the silica was 360. Now let's try a practice problem. With this practice problem, once again, I'll help you set up the bar model, and then I'm going to ask you to complete the computations on your own. A school raised $18,000 at a charity fundraiser. The money raised was shared among 3 different charities, A, B, and C, in the ratio of 1 to 2 to 3. So how much money did each organization receive? Let me help you get started by drawing a bar model. Organization A would have received a single unit. Organization B would receive 2 units. and organization C would receive 3. Our total amount is $18,000. From here, please go ahead and set up the problem, solve for the amount of money that each organization received, write your answer as A equals this amount, B equals a certain amount, and C equals a certain amount, so that I'm totally clear with what your answer is. Press pause, and when you come back, I'm going to give you one more practice problem before we wrap up today's lesson. Here's our final problem for today. The number of coins collected by Xavier, Johann, and Zachary is in the ratio of 2 to 5 to 8. Johann collected 85 coins. So how many coins did Zachary collect? And how many coins did Xavier collect? And how many coins did the boys collect total? Once again, I'll get you started by drawing the bar graph with you, or the bar model, with you, and then I'm going to leave you to do the calculations on your own. So our bar model would look like this. Xavier will have 2 units. Johann will have 5. And Zachary will have 8. Once again, please excuse the fact that my units are not totally precise. We know that the total number will be all of these units added together. We don't know what that is yet, though. However, we do know that Johann has 85 coins. With this information and the picture to help you, please go ahead and solve for the amount of coins that Xavier has, the amount of coins that Zachary has, and the number of coins that all 3 boys have together. We'll go over answers together tomorrow, and we'll also continue our work on real-world problems with ratios. These are fun. They're kind of like cool logic problems. I'll see you tomorrow. Have a great night. Thanks for your hard work.